Well, hello everybody. My name is Stephen D. Kelly. This is the Stephen D. Kelly Show. We are on Truth Cat Radio, the one and only www.truthcatradio.com. With the one and only Mr. Kitten as your trusty mascot. Hello to you people that are tuned in live. All right, what is it today? Oh, look at that. Is it really February 1st? Is it really? Wow, I guess it was. Jeez. Here I was. Yeah, oh well, whatever. It's now 6:01 p.m. All right, welcome to you guys. Now, I got to tell you, we're going to be talking about some quantum physics and quantum mechanics and fun stuff like that. But, I got to be honest with you that I'm really frustrated because of the world in general right now, humanity. And obviously, when I talk to you guys are educated, elevated, and all these great things. Obviously, you're listening to me, right? But sometimes when I go on Twitter, and of course, that's the big forum that we see, I get hit with the Trump stuff and the Biden stuff and liberal and uber conservative, and the war stuff and the Israel stuff, and it's just overwhelming. And I get hit with this just massive prejudice, shall we say, towards stupidity in general. How humans could allow these things to fester to the point that they are right now. Now, the other day in our Telegram group, Occupy the Getty / Stephen D. Kelly, which you should be part of if you're not, one of the members made a little post, and I got to it before it was deleted. And, because my admins, they tend to delete everything if it's not coming from me, unless it's, pretty benign or coming from somebody that we know. But anyway, this was about quantum physics, not quantum physics per se, but more quantum computing. And it was about an advance in quantum computing from qubits to Q modes. And I suspect that the reason why it was posted there was because the person posting it wanted my feedback, because I'm a laser person and I'm doing all this quantum physics and everything else and fun stuff. And, I'm sure this is difficult to understand. They wanted some feedback. And I'll tell you, my first response when I saw that was, first of all, this is an incredibly complex subject. And it's not just complex from a theoretical or a technological standpoint. It also involves information that I consider metaphysical, such as the concept of densities in the higher levels and scalar and where that comes from. So my feeling was that the article that was posted didn't really convey the information quite the way I would like to see it conveyed, because I'm kind of prejudiced, because I see things from the metaphysical standpoint. And to get even more hardcore, I'll tell you that I don't use technology. What they use technology for, I do with my brain, because scalar is actually manipulating reality, which we are going to talk about. So quantum computing really is delving into this 4D and manipulating reality in the 3D in the form of answers to questions. So there's two things that we're really going to talk about here. Well, there's lots of things. Hopefully I'll get to the, world stuff later. But first of all, let's just say that there's the physics, the quantum physics, and the quantum mechanics. Okay, so the physics basically are the rules and the laws that pertain to how things react in our 3D physical reality. Weights, specific gravities, interactions, having to deal with matter and their energies, electrons, this kind of thing, molecules, atoms. Quantum mechanics has more to do with manipulating these things, using these physical properties that are associated with, quantum physics, and using it in a way, using quantum mechanics to make it useful, like in computing or something of this nature. So we have to talk about the difference between these two things. It's kind of important because it's just like quantum computing. There's the theory, the technology, the concept, not the technology, but the technology is actually the physical machines. So in other words, if I say that quantum computing utilizes scalar and utilizes access to the 4D, and this is where it gets its efficiency and its exponential increase in efficiency, you have to understand that that's what that is. So any technology that's designed to try to implement this is a whole nother thing. So when someone says that you can do this, sure, you can do this, and that's what I really want to explain. And then there's the how do you do it. Now, we'll talk about the how you do it, but there's more than one way. Once you understand what a Q mode is, not a Q mode, but a Q byte, then you'll understand what it is actually involved in trying to manufacture these things. What are the ramifications? So let's talk about that here briefly. First of all, a conventional classic computer, as they say, is basically a bunch of transistors which are on-off switches lined up in such a way to create binary programs in massive amounts through photolithography. Interestingly enough, the technology involved in microphotolithography, especially electron guns and moving electrons and removing electrons, this is very much involved in actually creating semiconductors, but it's also very much involved in creating these qubits, which we will describe. So in a conventional computer, you've got millions, if not billions, of these semiconductors, these switches, set up in such a way that they can hold information and crunch numbers. Now, what is that? That's basically a tiny switch, mechanical, optical, whatever, but it's either on or off. It's either a 1 or a 0. 1 or 0, that's it. There's your binary language. So one of these bytes, one of these bits, one of these transistors is only going to produce a 1 or a 0. It's either on or it's off. That's it. So your ability to crunch numbers and the scale is going to be dependent on how many of these things you can have lined up. And it's going to get to the point to where you're going to have to deal with things like the speed of light and how long it takes an electron to get from one side of the semiconductor to the other. Now, obviously, that's an issue right now with the state-of-the-art semiconductor technology. Certainly, this is a major issue. We'll talk about that, but obviously, cryogenics is how they get these electrons to move faster. But there's other major tricks that they're using that are also very important. So those are the limitations, because basically it would take, if a conventional computer and a semiconductor let's say if you were trying to build using classical computer technology, semiconductor chips, CPUs, and if you were to stack those up in parallel and try to create some massive supercomputer, that would work. However, it would still have massive limitations. It would have massive cooling issues. It would take up a lot of space. But that's the technology that they use with these modern classic supercomputers. So what's the difference between that and a quantum computer? Okay, a qubit. This is a big deal. And this is where the physics comes in, and this is where the magic comes in. Because what we do when we create scalar waves, we're creating sine waves. And a sine wave is nothing more than the distance between 0 and 1. A sine wave starts at 0 and it ends at 1, and then it repeats that process. And what happens in between 1 and 0 is infinite. Now, in a switch, it's either on or off. In a Q switch, it has infinite possibilities. Now, of course, if you know anything about wave particles versus wave theory, which of course is a very big part of this electromagnetic spectrum thing, you'll know that as soon as you look at something, as soon as you measure it, it freezes. In other words, all of those infinite possibilities that something can be go to one thing when you actually measure it or look at it, which means instead of having a semiconductor switch, a byte, an on and off switch on a chip, they have a subatomic particle, in this case, usually an electron. Eventually, when we talk about the Q modes, we're going to talk about doing the same thing with a photon, which has a lot more information than an electron for obvious reasons, but we'll get there. So in each and every electron, there are multiple different possibilities magnetically and atomically. So in other words, at the very least, you can have a magnetic field that either goes up or down, but you can have it at the same time, you can have it go in opposite directions. And by manipulating an electron, you can change this. So here's the thing. So with an electron, your 1 and 0 are very much like the distance between the entire electromagnetic spectrum, which we know is infinite. So in other words, it goes in one direction and it goes in the other direction. So right away, there's two directions. The other thing is we know is between 1 and 0, there are an infinite number of fractions. 0.2, 0.4, 0.6, get it? 0.8, 1. That's just 10. There's actually an infinite number. Now, the fact that there is an infinite number, it's not just in one direction, it's actually in two directions, which means that you have a sine wave that has an infinite potential of shape. And as we know, much the same way that we know that a beam ship has to convert its matter into energy, and that energy has to be recorded in a specific sine wave, this works the same exact way. And this is really key to the entire process when it comes to computing. So, what does this mean? It means that there are the one direction and the zero direction. And the one direction could be horizontal and the zero direction could be vertical, the same way a scalar pattern works. So by manipulating this shape, you can actually create an interference pattern, which is actually used in this process for creating filters and algorithms. But that's in the technology part. So, what can I tell you about this qubit thing? Well, let's see. It's a stream of electrical or optical pulses representing zeros. Everything is from your tweets and emails. And I already told you that. Let's see. On the other hand, they use qubits, which are typically subatomic particles, such as electrons or photons. Generating managing qubits is an engineering challenge. Okay, obviously, IBM and Google and others have said they've done this. Now, before I try to get in exactly how these things work, I'll just say that there's a lot of skepticism. There's a lot of people that say this is nonsense and it can't be done. But to me, each and every one of these qubits, because as I tell you, it has multiple dual infinite possibilities, is exactly the best way to describe string theory. Now, if you look at an orb, it's the same thing. If you look at that electron that has all these infinite possibilities of magnetic aspects or sine wave features, frequencies, that in itself is the exact same thing as the particle described in string theory. And basically, the particle as described in string theory is that this energy, this soft energy, can be anything until it's observed, or in this case, intention determines what it actually is. Now, what does this mean? In computing, like I said, a single thing is either 1 or 0. In this, it can be infinite. One single qubit, just like one single circuit in a computer, an off and on switch, this thing can have infinite values between that 1 and the 0. Now, but the thing is that when you measure those values, it becomes either a 1 or a 0 based on which one it's mostly at. In other words, if it's an infinite number of values, but it's 51% 1 as opposed to 51% 0, whichever one's a little bit more, it's going to go in that direction. So the trick to making a quantum computer work is to be able to filter out the noise and filter out the infinite possibilities that aren't the answer. Now, isn't that interesting? It's kind of like Douglas Adams. But basically, this is how it works. Because as I said, there's infinite possibilities, and one single qubit can produce infinite values. We'll talk about how you use that, but the first thing is how do you get those infinite values out? Well, because qubits can represent numerous possible combinations of 1 and 0 at the same time, and essentially what they like to say is that this can be done, this ability is done simultaneously. They call that superposition. In other words, rather than saying each one has infinite values, modern technology describes this as almost as if there's infinite qubits within the single qubit. And they call this superposition. And they actually manipulate these things, so-called, they use precision lasers or microwave beams to do this. Now, once again, to me, this is like playing with soft matter to try to make it matter. We do it so much easier with our brains. Well, like I said, it's a matter of measuring it properly. There's a few other things that are important. There's one thing that's kind of important, and that is entanglement. Now, I also want to talk about the interference aspects, but entanglement is kind of important because entanglement is basically what allows us to manifest reality by essentially using our electrons in our body to manipulate electrons somewhere else in the universe, which is what manifesting is. This is how reality is manifested, is that we actually take this soft energy, this whatever you want to call it, these things that are very similar to these qubits they're trying to create, and we cause those things to become that which we are manifesting. I know that's the magic part. But basically, entanglement means that a pair, well, let's see, according to MIT, they say researchers can generate pairs of qubits that are entangled, which means the two members of a pair exist in a single quantum state. Changing the state of one of the qubits will instantaneously change the state of the other in a predictable way. And this is happening even if they're separated from very long distances. Now, in quantum computers, entanglement is used in a very close proximity because much like a classic computer, quantum entanglement is used as a type of switch. And in this case, rather than having the entangled electron on the other side of the universe like we do when we manifest, this time it's relatively close to another electron, but maybe separated much further than the normal distance of where an electron is going to be in relationship from one molecule to another. So they use, like I said, this, when they say microwave, basically these are what we call E-beams. In photolithography, they basically can cut a mask or a template for a semiconductor using a gun that essentially emits singular electrons. So in other words, an E-beam gun is going to have the resolution of, at best, a single electron. Now, I don't know if that's possible, but I would suspect that it is, and if so, they are trying to use this right now to basically move singular electrons in one direction or another at different places to cause changes. Now, because of entanglement, it's not just single pairs. These entangled electrons can be infinite, okay? They can be many of these entangled electrons out there, which means, and this is where the real efficiency comes from, which means that if your computer is based on electrons, which are your bytes in your computer, you may not have that many electrons, but because of this entanglement, each electron that you do have as a computer switch may have thousands or hundreds of thousands or millions of electrons working alongside of it in the quantum, okay? The quantum, the 4D. This is very important. This is the part that people just don't get. There's other issues like decoherence and quantum supremacy. But before I talk about that, I want to talk about something else. I want to talk about interference. Now, for me, interference, of course, is typically optical, because when I am doing measurement in the microscopic, in this case the sub-wavelength level, we use interference patterns. And these interference patterns are created by splitting a laser beam that has been exposed to a surface that you're measuring, reflected off of that surface. And that laser beam has a reference surface, okay? This is kind of important, this concept of a reference. So deviations of the item being observed with the laser, when that light that's been split from the laser and passes through the reference, and then another part of it passes through the specimen, when it's recombined, you can compare the difference between the two, and it produces an interference pattern. Now, an interference pattern is very important because it's information, but it's a different type of information. It's not a digital, it's more of a visual information. It's kind of different. Certainly, we can look at an interference pattern and we can try to analyze it. We can do this and that visually and with some, observational techniques. But technically, once again, we're talking about something that's happening on a very small atomic level. And we also know that when we do scalar, especially when we do it with our brain, that it's this difference between these, or this interactivity between the two waveforms that are put out by either side of your brain that are working at a 90-degree opposite. One's flat, one's vertical, one's horizontal. They call that orthogonal. This is the same thing that everything in the universe does. The electromagnetic spectrum travels in such a way. When we talk about waves and particles, waves travel one way, particles travel the other way. It's the same thing. It's all the same electromagnetic spectrum. The entire universe can be incorporated or you would say, able to be defined by the electromagnetic spectrum. And by the very same theory, by the very same concept, the same thing applies to every single electron. So a single electron can at the very same time represent the entire universe, essentially. It can represent the entire, theoretically, can represent the entire electromagnetic spectrum because it has infinite variables between its various different changes that can be caused by moving electrons around. This is the concept of these things. So, what do? They've got to create algorithms. Now, what can I tell you about algorithms? I have a little thing written here. I won't talk about that. Okay, algorithms are a set of instructions to solve a problem or accomplish a task in computing. Quantum algorithms require descriptions of what operations should do during computation on a quantum computer, which often takes the form of a software program called a quantum circuit. So in other words, the quantum circuit, which is this algorithm, which is a physically manipulated electron that is used to create this algorithm, because the algorithm is a complex sine wave or a complex set of instructions that can have infinite possibilities because of the infinite possibilities of this electron and the ability of this electron to connect to other electrons via entanglement. Okay? So what happens via entanglement is you can have an infinite number of electron positions based on the algorithm that you're trying to create. So basically, the entire computer is nothing more than an algorithm that puts in a question and spits out a single answer. The computer is configured to do a single computation. Each node, each qubit is built, is configured to produce a single algorithm, and the complexity of the computational ability of this thing is determined by the number of these qubits. Now, there has been a lot of speculation. It's supposedly, let's see, MIT, I'm sure, has done it. IBM certainly has done it. There are lots and lots of private corporations out there trying to do it in different ways. The Chinese have done it, and that's really scary. But Google has done it, and Google says that they created a quantum computer that has 35 qubits. I didn't get to talk about the interferograms yet. I've got to get back to that. And they say that with only 35 qubits, that they can configure that to do computations that are theoretically impossible to be done with a conventional computer. They say they can do computing far beyond the largest supercomputer. Now, of course, the Japanese are not the Japanese, of course, they're doing this too, but the Chinese claim to have created a system. I'm not going to go into too much of what they call their system, but they basically said that they were able to crunch a problem, a query, that would have taken conventional computers 20 million years, and they were able to do that in a fraction of a second, something of this nature. Now, when you understand that the ability to access infinite information, infinite data, infinite different shapes of a sine wave for each one of these qubits, you can understand just how powerful it is. Now, let me talk a little bit about this interference. All right, in an environment of entangled qubits placed in a state of superposition, there are wave probabilities. These are the probabilities of the outcome of a measurement of the system. Remember, the measurement's everything. These waves can build on each other when many of them peak at a particular outcome. That means when the sine wave reaches a certain amplitude, or a peak. Now, remember how we say that energy uses the highest vibration. The highest vibration always wins. That's exactly what this means, which means that the higher peak is going to cancel out lower peaks. Okay? And that's all what this is all about. There are probabilities of the outcomes of a measurement of the system. These waves can build on each other when many of them peak at a particular outcome or cancel each other out when peaks and troughs interact, i.e. sine waves. These are both forms of interference. It's actually visual when you think about it. It's kind of like, think of a sound wave. Think of how technology could be used to cancel out sound by producing a sine wave in the exact opposite of the sound wave that you're dealing with. Or how when we take, say, the program that you use to modify an audio program, an MP3, we'll go in there and we will modify sound waves. It's almost the same exact thing. A computation on a quantum computer works by preparing a superposition of all possible computational states. All possible. Okay? That's the word missing here is infinite. So in other words, every possible answer. In other words, you've got this is Akashic Records, people. A quantum circuit, which we discussed earlier, prepared by the user, uses interference. A master, in other words, a reference, selectively on the components of the superposition according to an algorithm, which is what this is. Many possible outcomes are canceled out through interference, while others are amplified. The amplified outcomes are the solutions to the computation. Okay? So in other words, you take every possible outcome that is out there, you calculate them all at once, and then you use your filter, which you have basically created by manipulating electrons using E-guns in a way that they describe in technology or in industry as microphotolithography, which is essentially moving stuff around on a tiny, tiny subatomic level. Well, that's how that works. So bear in mind now, you have two sine waves, one flat, one standing upright, going down a single path, traveling in multiple directions, and these sine waves have the ability to produce information in infinite amounts and all amounts at the same. In other words, all answers at the same time. And it's through this filter or this interference pattern or this reference that they create that cancels out all the other answers except for the ones that they're looking for, that this thing works. So why is that a big deal? Well, first of all, obviously, the technology involved in doing this, moving around electrons, creating Q nodes or Q, whatever you want to call them, Q bytes that stay working. In other words, when they set these things up, when they create these entangled electrons, or they entangle electrons with electrons who knows where, and they produce all these results, and they want it to stay stable. This is the difficult part. Because as I said, once they take a measurement, it all goes back to 1 or 0. So they've got these, each one of these things has been configured into these complex forms that they use as an interference program. Well, they use the interference program, things that they've created as a filter against these other things they've created, which give them every answer. All right, I'm just going to move right on to the Q modes real quick, but basically what's the big thing with the Q modes? Like I said, the Q modes, instead of using electrons, are using photons. Now, the big difference between a photon and electron is that a photon, of course, we like to think of as basically electricity or energy, or just this electron particle. A photon is actually a particle of light. A lot of people don't really, well, people don't think about photons because light is that thing that best describes the particle wave nature of energy, or at least what we think of as the electromagnetic spectrum. So a light beam can act as a single photon, and it can also act as a wave, depending on the, well, place that it is on the electromagnetic spectrum, what speed it's going, and everything else, how far away it is from what. The big thing to remember is that in one direction on the electromagnetic spectrum, the one that I like to think about, is that everything starts on the left side, which is the red, or no, actually everything starts on the left side, which is the blue and the ultraviolet, and then goes to the right, which is the red or the infrared, where numbers get bigger. At least that's how we look at it linearly. Now, if you look at the opposite direction, it's actually radio waves, which is measured in hertz. And of course, it's also displayed the same way because that's just the way we like to display information. But technically, it's the same electromagnetic spectrum. Only one of those things is flat, one of those things is 90 degrees or orthogonal or standing up, vertical. Okay, that's how it is. Now, the thing about a photon versus an electron is that in a photon, not only can it contain infinite frequencies or sine wave, but in that sine wave, it can contain infinite frequencies. In other words, colors. Okay? So in other words, from an interference pattern standpoint, interference pattern can be looked at as something that's either on or off, black and white as a filter. But a rainbow, of course, has multiple bands all going on at the same time. And this is basically what they're doing with the photon. And of course, this is new technology. They haven't really got this thing going on yet. But like I said, the Chinese are doing their best to leapfrog whatever we're doing. And so naturally, working with the Q modes is going to be the big thing. But let's say, what does it say? Q modes contain a whole spectrum. A photonic quantum computer could theoretically be faster than a qubit one. Oh, come on, is that really all you got to offer? Let's see. Scientists from the University of Tokyo have recently successfully used Q modes directly instead of relying on qubits, and future experiments will hopefully improve fault tolerance. Well, again, that's not really saying it, but this is kind of interesting. They refer to this, let's see, quantum technology, quantum Q modes, next generation quantum computers could rely on these retooled laser beams. That's rather than qubits. Let's see, sometimes referred to as continuous variable quantum information. Q modes are the information carrying units of a harmonic oscillator. In this case, light. Unlike qubits, Q modes technically contain an infinite number of states through process, though processors usually run with a finite amount of energy. So obviously there's an answer to you right there, that you can have an infinite number of this, but infinite number of energy. Where's that going to come from? Let's see. So understanding and building upon this Q mode concept could take quantum computers ever faster. Again, this is very vague. This is why I really don't like what these guys put out. But again, in a scalar system, not just a scalar computer, but in a scalar system designed to, say, transmit energy or receive energy, when you transmit a scalar signal, and when it is received by a scalar receiver, it becomes in well over 100% efficiency. In other words, the energy transmitted doesn't come back equal to the energy, isn't received in the equal amount that it was transmitted, it comes back infinitely larger. The same way this information comes back in a quantum universe with infinite amounts of information. And it's important that they are able to separate, using interference patterns, the information that they want. So they don't just run computations, they run every single possible computation. So once again, what does this mean? That means that if they can produce a filter or a Q mode specifically to break encryption using algorithms, atomic algorithms, Q circuits, quantum circuits, to break an encryption, once they have the quantum circuit set up, they can run all the particular, in other words, your password to your computer. If you have a computer running at this type of efficiency and ability, it could, within a nanosecond, probably compute every single possible combination or every single possible password that you could use for that computer. And by using its Q modes, it's not Q modes, but qubits, filters, interference filters, it could pick out everything that wasn't the correct answer. Just like that. It's like if you were to take a bunch of computers one by one, do the crunch in those numbers, 0001, 00, and try to come up with every single possible infinite combination of things that you, in other words, think if you're using a really stupid password like your birthday or something like that, how long would that take to crack? Even with a conventional computer, not very long. But with a quantum computer, the most encrypted encryption is going to be broken within less than a second. This is what's coming. Obviously, this is not good for security. Certainly, the NSA and people who are worried about that are worried about that. And obviously, at the same time, if you're using this for developing a disease, in other words, trying to come up with drug combinations that are going to eliminate a specific something that you've created qubits to act as the filter to look for, then yeah, you could find a miracle drug within seconds. Or you could calculate, I'd say, complex mathematics necessary to create really efficient atomic bombs really quick. This is what they use supercomputers for. Little things like that. You could calculate, movement of planets and stars in such a way that you could, travel the stars using the Akashic records. You could calculate probability and outcome, reality. You know what you could do with that? Travel time. That's how they make the algorithms to do that time travel. That's how it's done. You know what else you can do when you're creating interference patterns and you've got entangled electrons? You can change reality. Why not? Where are all those electrons out there that these electrons in this system are entangling to? How do you know they're not electrons in you, in your reality, that are suddenly being changed into something else? Your reality being changed. You wouldn't even know it. You wouldn't even know it. The more complex the algorithm, and trust me, it can be as complex as they want because there's infinite levels of complexity. They're just beginning to learn how to use this stuff. So yeah, entangled electrons is how we do magic. It's how we do healing. When I look at you and I think about you, my electrons entangle with your electrons. I raise your frequency of your electrons to where they need to be, to the highest level of frequency. We call that healing. Imagine what these computers can do with a little bit of information, say like your DNA or your photo. the kind of stuff that we use in our magic. But hey, this is magic, right? This is using technology to alter and manipulate the same bits of reality that we alter and we manipulate when we manifest, when we heal, and when we use our spiritual skills. So this is a spiritual war, people. And I'll tell you something. It's really important to share this with you, because I'll tell you, like I said, I was very put out about having to do this, because I'm frustrated with people. I mean, seriously, I'm tired of the stupidity. And I know you guys don't like it when I bitch about everybody being stupid. But come on. Now, it's like this little thing I shared with you right now. You're not going to hear this from anybody. You're just not. And if you did, it's not going to be very good. It's not going to be a good explanation. You're not really going to understand the impact. But like I said, the people who are involved with these computers and this stuff, they just want to make money. And you have to understand that if they're even talking about this technology, it exists. It already exists. If they're pouring money into it, they're pouring money into something else because they've already got it. And we already know that the enemy has the scalar capability to alter our scalar capability. We are not allowed to produce scalar technology or devices capable of altering humanity en masse, because the enemy has the ability to counter it, alter it. And this is why they were so upset. One of the reasons why they were so upset when I came up with the whole using a laser to transmit a scalar program. All right. But anyway, like I said, though, I hope you enjoyed this, and I hope I'm not wasting my time, but it's good for me when I do this, because at the very least, I'm learning something. I hope you guys are learning something, and maybe if I share this with you, you'll realize that A, everything else out there is bullshit, and B, this thing that you think is reality isn't real because it can be manipulated. Everything in our reality can be manipulated, and it's up to us to do better to overcome the technology with our magic, our ability to use scalar. I personally do it every day, and I'll tell you, thank God I can do that, because otherwise I'd probably go nuts from having to deal with all the stupid out there. All right, let me just kind of change the subject and wrap this thing up, since we're down to the last 10 minutes or so. I do want to thank all of you people that have joined the group, and recently I only see what we got. Hey, Santa Ana's listening right next to Utah. Help me spread this message and help me get more gigs on the internet, and try to get these guys that have lots of followers to have X meetings with me on there, that kind of thing, whatever they call that, spaces. Let's do that, because that's obviously helpful. I don't want to write you guys off, okay? I mean, I don't really want to try to kill myself explaining stuff that you just don't get, or you don't appreciate, or isn't going to have any effect on your lives. Over and over and over, I try to tell people that when we do open up the Getty, when we do occupy this thing and do this work, assuming that the enemy gives up, everything will become self-evident. And for those people that are in denial or question, well, you're going to probably have a hard time dealing with it. And unfortunately, the only way that's ever going to happen is if humanity, at least those people that are going to be responsible for making the changes, realize that it's not going to happen if you don't listen to me. That's really the bottom line. So, again, I guess my problem with the stupidity out there is that there is so many sources of misinformation and COINTEL information out there, and it's hard. It's basically frustrating and infuriating to have to beat people over the head to get them to see a different perspective than what they think they already know. So this knowing business, I don't know. If it's not experience, you don't know it. That's really all I can say. All right, before I go, though, I do want to ask people, if you're interested in helping me out, to please consider doing so. Looks like I'm going to have another toother done here. I don't want to think about that. I figure I'll take months, and I can save up over months, with the SSI and stuff. But I do appreciate those of you that do help, and if you are able to help, I need you to send your donation to my PayPal, which is StephenKelly714@yahoo.com. And of course, it's real important that you say it's for friend or family, so I don't have to send it back. And don't think I don't pay attention or I don't appreciate your guys' gift. If anything, sometimes one of you out there will send me a gift, and I'll think, oh my gosh, why are you sending me money? I feel so guilty. But at the same time, some people send it on a regular basis, and that's really helpful. And I just like to think that these guys are rich. They're really well off, and they can afford it. And it really does make a difference in my life, certainly, because it helps me take care of my teeth and stuff. Okay? And hopefully do more stuff in the future with the channel when we get big enough to reach more people. All right? Which you guys are going to help me do. All right, so again, thank you to you guys, especially the people in the Telegram group that have helped out, and you guys listening. I really do hope that even more of you get that passion and go out there and start doing the crazy work that we need to do. And again, Getty. That is really all there is to it. You need to push that stuff day and night, and you need to be a maniac and a crazy person when you do it. That's really the only way this stuff is going to work. Okay? All right, I hope you enjoyed the show. I hope you learned something, and if you have to, rewind it and do your Google searches and read through this stuff. But as we advance as a people, it's important that culturally we begin to understand these things, and especially you people that are listening to me, you need to understand these things so that you can lead others and be smarter. It's important. All right, so with that, I'm going to thank you guys for joining me once again, and my name is Stephen D. Kelly, and this is the Stephen D. Kelly Show, and we are Truth Cat Radio, www.truthcatradio. Already, people are bailing so quickly. Come on, what's the big deal? All right, and but again, thanks. So, good night, God bless, adios, and goodbye.